law. Next topic. Basically, it says that the two charges kept at a distance r apart exerts force on each other. With the magnitude of that force is proportional to the product of both the charges and inversely proportional to the square of the distance between the charges. Okay. So as shown in the figure, there are two charges Q1 and Q2 kept at a distance r apart. The force magnitude is directly proportional to Q1 into Q2 and inversely proportional to r square. This is one like this. Okay. So combining the two equations, you have F is directly proportional to Q1 Q2 by r square. When you remove the proportionality sign, a constant needs to be added, and that constant is 1 upon 4 pi epsilon naught. This quantity is read as epsilon. This naught stands for vacuum or free space. It is the it takes into account the property of the medium, which is known as permittivity. We'll come to that on later. So coming back on the force equation again, so F is equal to the constant 1 upon 4 pi epsilon naught into Q1 Q2 by r square. Given that this two charged particles are placed in the vacuum, the charged particles are point size in nature. So there is a simple force equation between the two charges. The magnitude of the force is given by F equals to kq1 F equals to 1 upon 4 pi epsilon naught Q1 Q2 by r square. This 1 upon 4 pi epsilon naught is also sometimes taken as a constant, which is k. So you can also write F equals to k Q1 Q2 by r square. Okay. Yeah. So this formula gives us the magnitude. Force is a vector quantity. So for direction, what we can do, we can just remember two concepts, that the concept or the thought in the properties of the charges, that the like charges will repel each other and the unlike charges will attract each other. So this is shown in both the diagrams 1 and 2. In the first diagram, there is an attraction because Q1 and Q2 are of opposite charges. When Q1 and Q2 are of opposite charges, the product Q1 into Q2, for attraction, the product Q1 into Q2 will always be less than 0, because if Q1 is positive, Q2 is negative, so product negative. And again, if Q2 is positive and Q1 is negative, the product is again negative. So whenever there is an attraction, Q1 and Q2 will always be less than 0, and so the charges will attract each other, and the force diagram is shown in the figure. Q1 will get attracted towards Q2, so force on 1 is shown on the right side, whereas the Q2 will get attracted towards left side, and show the force is shown towards the left side. And the second case, when Q1 and Q2 are opposite, when they are like charges, that is, the product will always be positive. So when there is a repulsion, Q1 and Q2 will always be 0. Whether they are both positive, so in that case also positive into positive is positive. And for the second case, when Q1 and Q2 both are negative, Q1 into Q2 will be again positive. So when Q1, therefore this condition is written, Q1 into Q2 is positive, that there is always a repulsion. And see the force diagram, the force on Q1 is towards the left side, meaning the right, that is the Q2 charge, is pushing away the Q1 charge. Similarly, the Q2 charge is pushed towards the right side by Q1 charges. And this force, attraction and repulsion, is always along the line joining both the charges. So this is always along the line joining both charges. Okay. So what is this line joining along both the charges? So यहाँ पे Q1 है, यहाँ पे Q2 है. So this is the point connecting the charges, and let's say Q1 Q2 is less than 0, that is, there is an attraction between them, they are like charges. This is positive and this is, let's say, negative. So when representation of force vector for first charge will represent on the line like this, for the second will represent on the Now moving ahead, effect of medium. As I said, we will come back to this property later. So the force magnitude changes if the medium is changed, and for that we have taken a constant into account, which is permittivity of a medium. Basically, permittivity represents how the field lines penetrate inside the medium. We will study the concept of field lines a bit later. So it if we don't go into the depth of permittivity, it's okay. We can just understand permittivity as, in a simple line, the electrical force magnitude depends on the medium, and that consideration of the medium is taken into account in the equation using a constant, which is permittivity of a medium, or permittivity. For vacuum, the permittivity value is mentioned here, that is 8.85 into 10 raised to minus 11 Coulomb square upon Newton meter square. And as I said, you can use also a constant K for 1 upon 4 pi epsilon naught, and by putting the values of 4 pi and epsilon naught, you will get K roughly as 9 into 10 raised to 9 Newton meter square upon Coulomb square. Okay. Now, what happens if the charges are not kept in vacuum? So if the charges are kept in another medium except vacuum, so the proportionality says as it is. Okay, so the proportionality Q1 Q2 by R square stays as it is. What changes? So when you remove the proportionality sign, now the constant is still the permittivity, but not the permittivity of vacuum. यहाँ पे हमें जिस मीडियम में इसको रखा गया है, पूरे सिस्टम को, उस मीडियम की परमिटिविटी हमें यूज करनी है. ऑब्वियसली हर मीडियम की परमिटिविटी अलग अलग होती है, और जो लर्न करने की जरूरत नहीं होती वो इनडायरेक्टली या डायरेक्टली क्वेश्चंस में मेंशन ही रहती है. बट द पॉइंट बीइंग, द मैग्नीट्यूड ऑफ द फोर्स चेंजेस इवन दो द चार्ज वैल्यू एंड द डिस्टेंस बिटवीन द चार्ज रिमेन सेम. दैट इज द point to be observed. The value of the force changes if the medium changes for the same charges kept at the same distance. And this epsilon value is a constant. It's a property of a material or a medium, you can say. And the values for different mediums are known to us, but we don't have to remember or LBH. It is given directly or indirectly in the question itself. So now, instead of learning or using the values of epsilon directly, we have developed a term which is known as relative permittivity, which is epsilon r. It is simply written as permittivity of a given medium upon permittivity of vacuum. So what does relative permittivity does? It measures the permittivity of any medium with respect to vacuum. I'm repeating. Relative permittivity measures the permittivity of any medium with respect to vacuum. Normal permittivity values are measured with respect to 0 or absolute permittivity. Relative permittivity is measured with respect to vacuum. इसका मतलब प्लेन शब्दों में ये होता है कि वैक्यूम की कंपैरिजन में एक गिवन मीडियम की परमिटिविटी कितने टाइम है, उससे एक गुना है, एक गुना तो नहीं होगी, एक गुना तो वैक्यूम इटसेल्फ हो गया, बट उससे 2 गुना है, 3 गुना है, 2.5 गुना है. अगर 1 से कम हुआ तो परमिटिविटी गिवन मीडियम की उससे कम होगी, बट फॉर अ फैक्ट परमिटिविटी ऑफ अ गिवन मीडियम वैक्यूम से कम नहीं हो सकती. सो एप्सिलॉन आर हमेशा 1 से ज़्यादा ही आएगा. ओके, सो एप्सिलॉन ऑफ एनी मीडियम कैन बी रिटन एज एप्सिलॉन आर इनटू एप्सिलॉन नॉट. We can easily practically measure epsilon r. So therefore we use epsilon r mostly in place of epsilon. जहाँ जहाँ epsilon हमें चाहिए वहाँ हम उसको replace कर देते हैं epsilon r into epsilon naught से, because epsilon naught is a constant thing and epsilon r can be measured pretty efficiently. Therefore, so this is the derivation. At the end of it आपको सिर्फ याद क्या रखना है, this equation, that for same system the magnitude of the force is always magnitude of vacuum divided by epsilon r, that is relative permittivity. And sometimes this relative permittivity is also known as dielectric. For some particular case, that particular case we'll study in the topic of capacitors. So yeah, so just डेरिवेशन कुछ काम का नहीं है, आपको सिर्फ ये याद रखना है कि अगर सिस्टम को हम वैक्यूम में रख देंगे, सॉरी कोई और मीडियम में रखेंगे वैक्यूम के अलावा, तो जो फोर्स होगा वो हमेशा सेम सिस्टम जब वैक्यूम में रखी गई हो, दैट इज के क्यू वन क्यू टू बाई आर स्क्वायर, वेयर के इज 9 × 10⁻⁹, उस वैल्यू को अगर आप रिलेटिव परमिटिविटी से डिवाइड कर दो तो आपको न्यू फोर्स इन अ गिवन मीडियम मिल जाएगा. Now vector form of Coulomb's law. Again, the derivation is not important. You just need to remember this two final equations. This is just the representation of Coulomb's law in a vector form, and it should be learned because MCQs कभी कभार आ सकते हैं. So using this diagram and this symbols you need to learn, that is force on F12 is force on 1/2 and F21 which is force on 2/1. So there is nothing new here. We just need to remember one simple rule of vector, that any vector A can be written as its magnitude into its direction. Direction is always given by the unit vector. So we'll use that instead in writing this force equation. So we'll have F12 equals to, as you can see, the magnitude is k q1 q2 by r square, and we need a unit vector and which is r12. And if you are using, this is the displacement vector, unit vector, if you are using displacement vector itself and not its unit vector, in that scenario there should be cube here to maintain the unit of Newton, to maintain the unit of meter square in denominator. Okay. Similarly, for F21, you have the magnitude should be same, obviously. The unit vector is R21 now. And again, if I am using a vector instead of a unit vector, the denominator should be replaced by cube. Here R is the magnitude of the displacement vector. So R12 and R21, both, as you know from vectors, have the same magnitudes. Okay. Now, one more thing, that Coulomb's law follows Newton's third law of motion. Which is written, which is shown in the PDF also, this equation, that F12, here is the proof, but we don't have to remember the proof. कुछ काम का नहीं कॉम्पिटिटिव एग्जाम्स में उसका, और कोई सम्स यूज भी नहीं होता. सिर्फ ये याद रखना है कि न्यूटन्स थर्ड लॉ जो है वो मोशन का थर्ड लॉ फॉलो करता है. न्यूटन्स थर्ड लॉ ऑफ मोशन इज सिंपली force on 1/2 is equal to negative, or is equal to in magnitude force on 2/1, and the direction will be opposite. एग्जाम्पल, अगर ये Q1 चार्ज है, ये Q2 चार्ज है, रिपेल कर रहे हैं एक दूसरे को, तो Q1 इसको यहाँ धक्का मारेगा राइट साइड पे. रिपल्शन मतलब धक्का मारना, पुश करना उससे दूर. ये this red dotted line is the line joining the two charges. So Q1 चार्ज Q2 को पुश करेगा उससे दूर, so राइट साइड एरो बनेगा, तो फोर्स ऑन 2/1 राइट लगेगा. तो उतने ही मैग्नीट्यूड का, अगर सपोज ये 10 न्यूटन का फोर्स है F21, तो 10 न्यूटन का फोर्स Q1 चार्ज पे भी लगेगा, बट कौन सी साइड लगेगा? लेफ्ट साइड लगेगा. ओके. तो मैग्नीट्यूड वाइज दोनों सेम होंगे, बट वेक्टरली बोथ विल बी इक्वल एंड अपोजिट. So now force between multiple charges. So if in a system there are more than two charges, then force on any charge is vector addition of all the forces acting on it. For example, I have shown here and three charges placed on the vertices of a triangle with values q1, q2, and q3. The distance is r12 between 1, 2, r23 and r13. So let's say I'm calculating the force on the first charge, or let's say here third charge is mentioned. So I'm calculating the force on the third charge. with थर्ड चार्ज पे कौन कौन फोर्स लगाएगा? ऑब्वियसली उसकी विसिनिटी में सेकंड चार्ज भी है और फर्स्ट चार्ज भी है, तो थर्ड चार्ज पे सेकंड चार्ज का भी फोर्स लग रहा है और फर्स्ट का भी फोर्स लग रहा है. So the net charge on F3 is always equal to the vector addition of due to the forces because of the second and the first charges. Okay. This vector addition needs to be performed using the laws of vectors, which you have studied in the previous chapter 11 standard की starting with the vectors chapter में आपको laws पढ़ाए थे. उसी law से vector addition perform करना है. And yes, the net force on the any charge, let's say यहाँ पे third का example था, that is equal to the vector addition of the two charges, but also the dynamics equation with the any force, the net force is always equal to mass into acceleration is also valid. So if you have been asked to calculate the acceleration of the third charge, it is simply the net force on the third charge divided by mass of the third charge. Okay, so remember this, the dynamics logic, that the net force is always equal to mass into acceleration. Now, if there are more than 3 charges, for n charges present inside the system, you have net force equals to F1. The net force F is always equal to force on M1 by 2, force on 1 by 3, force on 1 by 4, and up till the force on the first charge by n. So here it will be F1, that is the net force on the first charge. Okay. So this is complete Coulomb's law, or you can say the concept of electrical force, the force between the two charged particles or multiple charged particles. Now the next topic will move on to the electric field.